and the advancers here. All right, thank you very much for that very brief introduction. Yeah, actually, I have followed a lot of speakers in my career, but I've never followed Harry Potter. What? Well, I tell you what, we're in good hands. Those are three great speakers, I'll tell you what. I was nervous, Nelly, when I started out a long time ago. In fact, speaking of a long time ago, I wandered in here yesterday and I was talking to Bernie over there with Lethbridge Community College. 30 years ago, 30 years ago, I did a one-year stint at the college and then off to Saskatoon, and the rest is history. But yeah, it was fun. It was fun. I still come back here and I still have good friends and I still have good conversations. So I was asked to chat about probably the only livestock conversation in this conference, and so a little bit about pasture management, forage management, and the impact on a couple of characteristics, specifically soil, and the other one, enteric emissions, which I get a little bit jaded about, I guess, going forward, is the finger pointing going on at the beef industry. And yeah, what do I do? Well, that's what I do. I do applied cow-calf and forage research, and I've done that for probably over 30 years now. Just looking at what we can do to solve. How many livestock people in the audience today? And I'm talking large ruminants, maybe, I will count small ruminants too. Sheep and goats are good. Okay, so yeah. So we have a few folks, but really it's all about, our programs looked at everything to manage that gestating cow, that calf from birth to harvest, obviously breeding programs, grazing programs, everything. And I started out many years ago looking at a lot of performance indicators in our research program, and weighing calves and clipping grass and those types of things. But in the last 8+ years, I've been asked to look at the synergies between the beef industry and the environment. And so trying to get the data, collect the data to look at the interactions of the industry and the environment in the field situation, because if we don't have that data, I'll tell you what, the policy people are going to model it, and that's pretty scary. So we're doing our best. Yeah, as I said, went out to U of S in 1984, and the rest is history. But for 25 years, I was at Lanigan, Saskatchewan, which is about an hour and a half east of Saskatoon. And there's about 12 quarters of land out there. And really, that was my lab, was the cow herd and the land, and doing applied cow-calf and forage research, and things change, and funding changes. And so then in 2018, the province got together with the university and the industry, and we relocated to Clavet, Saskatchewan, which is about 20 minutes off campus versus that hour and a half east. And so kind of neat to be part of building a new facility, a new research facility kind of under one roof, so we can integrate the vet college faculty and the egg college faculty and other third-party industry companies as well, just looking at beef cattle related research. And that field that you see there on the left was just a canola snow rotation before we got out there. So, oops, I'm sorry, I pick on cropping guys here. It was kind of neat because I'd never seen a four-legged ruminant. And so we're able to really follow a lot of nutrient cycling from the grazing critter. Fun stuff. Yeah, and so my whole program is all about integrating forages quicker, sooner, longer throughout the calendar year in front of that mama cow. Forages, forages, forages. When I finished grad school, it was a forgotten cousin. It was a swear word. Never got a proposal supported when we put that in the verbiage. But nowadays, it's crazy, crazy. Everybody's talking about forages. So, and we've looked at lots of forages over the years, annual perennials. This is just one teff grass because we are living in about 3 or 4 years of straight drought. I know you folks have experienced drought here, and there's a lot of ranchers are suffering immensely. So we're trying to find out what are these opportunities or alternatives to get to grow some fiber for your critters. In drought years, we're looking at ways of salvaging cash crops. And so we've looked at obviously grazing canola, flax, peas, lentils, everything. It's amazing what that ruminant can digest. But teff grass is a warm season, and it's one that we're looking at how it persists and performs in a dry drought situation. Another one is this guy, a forage chicory. It's an interesting one. We're having a challenge getting it established and overwintering, but certainly there's some side benefits with this one, and that is the anthelmintic potential. So it might even control worm burden in your critters. And so I have a student working, trying to investigate that further. Okay, and so many of you have heard me speak. It's all about economics, and any numbers I tend to throw up are the numbers that we gather in that research study in that year that we did it, in that location that we did it. And so it really is a chance for you to compare and look at what are your costs on your farm or your ranch when we're up here throwing some numbers at you. But I've worked with an economist, Kathy Larson, for many, many years. And certainly we know that the feed costs going into the fall of 23 were a challenge. The price of hay, the price of straw, if you could find it, was a big, big challenge. It's no different. How are they going to winter their cow herd? But what's also interesting, and this is the 550 weight variance of the price of that steer over about a 20-year period. And you can see that it varies, okay? And what's also surprising, and we had some high record years in 2015. Anybody look at the sale barn lately? Unbelievable, unbelievable. And that, my friends, on the left is the weights, and on the right is the price per animal. $2,500 to $3,000 a pop, okay? So finally, you guys are being compensated for your critters, finally. And I'm talking to Brad Welter, who's running Poundmaker Feedlot, the biggest feedlot in Saskatchewan, 28,000 head capacity, 2.5 flips and ethanol feedlot integrated facility. And they're placing these guys at that price. And they're seeing some profit from these guys. Why? Because the feed ingredients are moving. Okay, barley's moving a little bit, so they're seeing some profit. But I'm just saying, finally the industry and the cow-calf guy is getting some compensation. All right, so I'm gonna get on my soapbox and be a little evangelical here. But how did the Northern Great Plains evolve? Under the grazing patterns of the ruminants, right? The wild ungulates, the bison, the deer, the elk, the pronghorn, okay? So the 99% of people that don't know where their food comes from, they don't know this. And it's up to you folks to tell them. And those young ag advocates that I talked to in that table over there, those college students, the students that I lecture every day at U of S, okay, is to remind them that guess what? The Northern Great Plains evolved under the grazing of these wild ungulates. And so these grasslands, these forages, these rangelands that we see today are there because of those grazing patterns, okay? Got to go backwards. Okay. And the other thing is that those more fertile soils, okay, we plowed up and now we grow cash crops, but there are still remnants of shortgrass prairie, mixed prairie, tall fescue prairie, all those, they're still there. And we need to be aware of those and we need to preserve those. Okay, grazing. Grazing is it's a balanced disturbance, okay? It's one that we can control. Okay? The critters aren't going to control it. They're going to go out there and they're going to willy-nilly graze that plant and that plant and that plant. But grazing, when we have a human intervention, can be very a balanced disturbance. It stimulates growth of herbaceous species. It encourages root respiration and exudation. Increases tillering. That's the way that most native species reproduce, is tillering, because they don't set seed every year, right? Because they're smart. They're not going to put seed head up if it's really dry or not ideal conditions. So tillering and rhizome production. And then we talk about soil organic carbon. We talk about stocks. The big buzzword right now is carbon sequestration, okay? And I think we all have heard about that. So what does that mean? How do we measure it? Does it move? Does it go forward or does it go backwards? I'm talking to several people. I work with a team of soil scientists. And you know what? We can look at carbon levels and they'll be static. In fact, they might inch up a little bit after a decade, and then they'll go backwards. So it's just not, if we grow that crop after 1 year, we're going to see soil organic carbon increase? No. It's a long-term commitment. It's a long-term measurement. All right, so intensity of grazing. That's the amount of material above ground biomass that removed from your grazing, with your grazing critters, right? And can we impact soil organic carbon and enteric emissions, and why? What is that? I was in Battleford last Friday talking, and the ducks guy knew what it was. It's a rock. No, what is that? Starts with an L. Litter. Litter, people. It's a producer's insurance policy. It's what protects the soil from that heat, those hot 40-degree days. It captures those 1/10 rainfall, okay? Litter, litter, litter. That and soil organic matter can increase soil aggregation, right? So the ability of porosity within the soil to percolate down those 1/10 rainfall events. Infiltration rate, something that we're going to measure this year going forward. Decrease runoff and soil surface evaporation. So litter is a blanket. It's an insulative layer that we need to think about when we're grazing our pastures, be it tame or be it native range. Okay, what does that mama cow do? Well, she does lots of things when she's out there, right? She's impactful, and only we can control her impact. There's a direct influence, biting, trampling, urination, nutrient cycling. Indirect, habit environment modification. Immediate or delayed, and can persist for varying lengths of time, depending on how long they're out there, the stock density, and the stock rate, right? So timing, intensity, frequency, and duration. The 4 things you need to remember when you're talking about range management. It can compact soils. And you know what? Soils must be rested. Just like the grass needs to be rested, the soils must be rested too to overcome the effects of grazing. If we have too high of a stocking rate for too long, that can be detrimental as well. And then we see this too all the time, is what's going on below ground, right? We're always looking at what's above ground, but what's happening below ground. Sometimes we forget about that. Lots of things are happening, especially with the root biomass. There's just a figure that I see coming up time and time again. What is soil health? Okay, we hear about that. What is it? Well, I still struggle to come up with the right definition. As I said, I work with soil scientists. I'm a ruminant dude. I'm a forage management dude. And so I just surround myself with people that know more about me, more about soil than I do. But really, it's the blending of physical, chemical, and biological factors. So I've come to understand that. And so far, we've just been looking at the chemical aspect, the NPK and S. But then we have to look at the physical, the aggregation, right? And now we're hearing about the biological, the bugs that are below there. What are they doing? And so I'm teaming up with someone like Dr. Bobby Helgeson, who's a soil microbiologist, so she can further explore that, put a couple of grad students on that study, and we probably, hopefully, will have a good story to tell. All right. This is looking at the pathway of changes in the hydrological condition of a site. So what happens with water infiltration, okay? Whether or not you increase grazing, increase stock density, increase stock rate, intensity, and frequency, like I mentioned previously, obviously there's going to be a decrease in cover, a decrease in soil, in water infiltration, all those things. The opposite happens if you decrease grazing intensity and frequency, okay? You allow it more time for those small rainfall events to percolate down and those species to benefit. Okay, so we know that grazing is a disturbance factor. We know that we as managers can control stocking rate and stock density. Now we're going to talk about what are some of the alternative systems that are out there. And this is one that I always talk about, and many people talk about, that kind of is the ad hoc default system. It's called the continuous graze system. What do? We put them out there in the spring, and then we go find them in the fall, right? And that, my friends, is a continuous system. It allows those critters to go out and selectively graze different species, grass, forbs, woody plants, all those types of things. One paddock, one period, no restricted grazing, and can be damaging. Very, very damaging, as some of those pictures relate. It's a traditional grazing system, unfortunately. And this is the big thing. There's no rest period. There's been no rest, right? Those plants need rest. They need to charge up the carbohydrate reserves. It can be damaging to rangeland health, going from good to fair to poor. And it's very simple. You don't have to think about it. We always kick those cows out in the back 40. They hammer the heck out of it. Okay, so what? I'm kind of focused on my cash crop program. That's my enterprise that's making me money. Well, I'll tell you what. In Battleford, I talked to 4 young guys, and I'm talking young being 35-ish, and they were trying to pencil out cash crops in that unity country. They couldn't. With the price of critters, they had some old tired pasture. Then we were talking about sod seeding, and they were looking at maybe some profit. Putting some livestock out there is maybe a different enterprise for these guys. The big thing about a continuous system is that word there called overgrazing. So the animals go back and they regraze the regrowth of the plants they bit previous. Okay. The true definition of overgrazing is successive defoliations on the same plant without adequate rest in between. It needs rest to recover. And of course, the big thing is that input costs are low. So you look on the left here, this pasture was stocked with balance in mind and rested, and I hope that one on the right doesn't look like what you have at home. Okay, that was stocked beyond what resources will bear. Now here's the alternative, and we're hearing lots of conversations about this. AMP, adaptive multi-paddock, high intensity, low frequency, okay, short duration. Lots of names for this grazing system, but we're seeing lots of conversations about it in the last probably 5, 6, 7 years, especially when we talk about improving biomass and looking at carbon stocks and these types of things. What is it? Well, we're trying to mimic what those wild ungulates did, those tens of millions of bison did before European settlement. On the left is your conventional system, okay? And on the right is your AMP system. So what we're doing, we're fencing off, and we could be 2 paddocks, we could be 24 paddocks. It depends. Every farm and ranch is different. Every farm and ranch is a different case study. So it's a sustainable grazing system based on a lot of the research and the producers that implement this system. Really, it's a high stock density for very, very short period. So we're talking what? We're talking now 10,000, 50,000 pounds per acre, maybe 100,000 pounds per acre. You're in, you're off. Okay, you're in, short time, you're off. So I always use the example where if I have 5 steers, okay, and I put them in a 40-acre field for 1 month, those 5 steers have all day to figure out which plant am I going to graze, right? Very little competition. Now I'm going to take 500 steers and put them in that same 40-acre pasture. Okay, so when that 489th steer is wanting to bite that plant, too late. His buddies have already bit it. We're taking away preference, palatability, and grazing behavior. So it's all that, it's that Jones and Sandland curve, right? Where does stock density meet where we're seeing, yeah, individual animal performance is going to go down, but overall beef production per hectare is going to go up or maximize at the inflection point. But it needs rest. We're going to come in, we're going to graze it, we're going to hammer it, but a long, long rest for those plants to recover and the potential to improve soil quality. And again, you can see the difference, right? This pasture really was thought about with our manager at Lanigan at Western Beef for all those years, certainly had an eye for pasture management. Okay, what does some of the data say in terms of biomass and quality with AMP? Well, there's some work by Hildebrand showing 3 times more yield in AMP versus continuous graze, 74% higher biomass in AMP versus continuous graze by some of that work by Wang. And we look at nutritive value, okay, protein, mineral levels too, you know, in rotational pastures greater than that continuous graze. And we look at starch content too in AMP versus a light versus or a heavy continuous graze. So some opportunity there to maybe improve the biomass and improve the quality. Again, some other work by Hildebrand showing on the left, you can see that the AMP In terms of biomass, yes, it's a gram per meter square, which is pretty small. We just extrapolate that to kilogram per hectare. But on the right were the two continuous graze, greater level in that AMP. What about this factor? Remember, the animals are out there. The pulling of the tufts, right? The impact, the hoof impaction, all of those things are disturbing that plant, not killing it, but disturbing it to a source sink relationship, move those carbohydrate reserves from the roots, and grow a new above ground biomass. So looking at more palatable species and reducing unpalatable species, some of that work by Wang. Decreased weed species. We know weeds are a problem, right? Weeds are nutritious. The problem with weed species is they have these anti-quality factors. They have glucosinolates, right? They have prussic acid, all these nasty things that a ruminant doesn't really like. I mean, red root pigweed, lamb's quarters, yeah, they're nutritious, but we have to be aware of the anti-quality factors. So that hoof action, that trampling, really incorporates that litter I talked about previously into the soil, improving soil structure, nutrient content, and increasing that water infiltration. It's so huge that that water percolates down through those layers and not run off and evaporate, especially when rainfall events become fewer and farther between. We all know about that. Again, some other work by Wang showing the diversity of species that are out there in an AMP versus continuous graze. And I just highlight the AMP on the bottom here. Look at the diversity of grass for plants compared to the above, which is the continuous graze. So more diverse species of grass and legume species and woody species compared to that continuous graze system. What about some of the effects on soil organic matter and soil organic carbon? Well, there's contrasting reports, okay? In some cases, and this goes back with some of that work by Dormar and Wilms, showing that the soil organic carbon decreased under a heavy graze on a rough fescue grassland after a long-term study, okay? And that's a rough fescue grassland. Then we look at some other work. Late and light graze, increased litter soil organic matter and soil organic carbon. This is some of NACE work out of U of A. Versus the early and the heavy graze where it decreased litter, soil organic matter, and soil organic carbon. Water infiltration, okay? It sequestered 1.37 ton per hectare more carbon than your continuous. Soils under AMP had 13% higher soil carbon than continuous. AMP had higher soil nitrogen stocks compared to continuous, and also water infiltration rates were greater, and decreased surface runoff was less, and decreased stream flow was less as well. Here they're comparing cultivation versus restored grassland, okay? So soil organic carbon mass was higher in grassland versus cultivated land after an 8-year study by Nelson. Sod-seeded legumes, some of the work by a student out at U of S. We looked at sod seeding slice of milkvetch and sandfoin, showed that it improved forage quality and maintained soil carbon stocks after a 4-year program. And in perennial pasture systems, Poston's work there looked at soil organic carbon cycles more slowly, leading to more secured net amount. Okay, so that's the conversation about soil organic carbon. As I mentioned, it takes a long time to move. We religiously try to measure it. I'm going to talk about a program here in a minute, the federal program that's involved producer cooperation. And so we have to be patient. We have to be aware that it's not going to be an overnight fix. Now let's talk about this other thing, enteric emissions coming from your grazing critters, okay? The ruminant's kind of a neat system where it has that relationship with the rumen microflora. I call them the rumen bugs, okay? And what they do is they utilize those low quality, high fibrous feedstuffs, and it's actually the bugs that attach, release their enzymes, and break down that feedstuffs to 3 short chain fatty acids, specifically acetate, propionate, and butyrate. The issue with this particular fermentation vat is it produces a lot of gas. Okay, every day these cows are out there burping off these gases, this eructation process, right? That's where the science is focused, is on the level of CO2 and the level of CH4, which is methane. And those levels of gas emitted will vary depending on diet, pH, the population of bugs, and of course the variability in those 3 short-chain fatty acids. So as I said, the feedstuffs hits the rumen, broken down by the bugs. There's your 3 short-chain fatty acids. What the neat thing is that in production of those 2, acetate and butyrate actually release hydrogen ions. And so you think about that, there's a lot of hydrogen ions booting around that rumen, a pool of hydrogen ions looking for a home. And what they do is they find a carbon skeleton, and henceforth that's a synthesis of that CH4 done by those methanogens, okay? The interesting thing is production of propionate actually uses a couple of those hydrogen ions, okay? We see that that acetate to propionate ratio is greater on a feedlot concentrate type diet. So we're seeing less methane emissions from the feedlot sector because of the concentrate grain-based diet, more of acetate propionate ratio in that cow-calf sector because they're largely grazing forages, largely grazing those fibrous forages, okay? That's why the finger pointing is going on at the cow-calf sector right now for enteric emissions. Just saying. How can we reduce those emissions? And I chatted about this last week in Winnipeg and a couple of places where I was talking in Saskatchewan. How do we do that? Okay, how can we address this? Because it's different than a pen system, different than a feedlot system. Well, we can do it by supplementing fat in the diet, up to about 6 to 7%, okay? Well, it won't have a negative effect on rumen microflora function, or maybe we can look at integrating a higher quality species in that pasture, specifically a legume. And we go back to some really dated work there, but they were looking at this in Brandon, Manitoba a long, long time ago, showing that that binary mixture of alfalfa grass had less emissions than a straight grass pasture. So that's kind of where my program's been leading, is looking at integrating all these different legumes that are out there, both bloating and non-bloating. If we're panicking about alfalfa in our rotation, we have the non-bloat options. The sandfoin, the bird's foot, the sisal milk vetch, okay? Those, my friends, are tannin-type legumes without sisal milk vetch exception, but certainly sandfoin is. So what are we doing at our facility? Well, we're looking at this. We're looking at trying to integrate these legumes in different systems, and we're actually trying to measure what's coming out of the front of that cow. I've been lucky enough to travel a lot around the world, actually, with my research, speaking in many different countries. And so I'm over there in Queensland, some years ago, and we're on a tropical pasture tour, okay? And there's those weaner cattle. That's those Bos indicus humped cattle, okay? Brahmer type cattle. And what they have a unique problem, probably like our southern Alberta with our native rangeland, where the quality of that grass goes backwards. It's only about 4 or 5% protein. Those bugs need about 6 to 7% protein to meet their requirements, your rumen bugs. So their protein requirements are not being met, especially with that warm season native range grass, sitting about 4 or 5% protein. So what do? They plant these leukemia trees, a nitrogen fixing tree. And the critters go out there, they put their foot over the tree, strip off the leaves, there's your protein supplement. It was crazy weird to watch them go out there and utilize that and get that protein sup. These leukemia trees, as you can see, have these condensed tannins. So very high digestibility and very high protein content. So they complement that warm season native grass found in that tropical pasture that sits about 5% protein and very low energy there, you can see. And when they go out there and they utilize that protein sup from those leukemia trees, they're able to double that live weight gain on those weaner cattle. So what can we do here in Alberta or Saskatchewan? What can we train our cows to do? What's growing in every farmyard? Caragana. Yeah, thank you. You win the hat. You're welcome. But there must be something about Caragana bushes that are not palatable, okay? Yeah, the spikes too. So, I mean, it's kind of neat to see these things happening in other countries and say, can we bring it back and adopted here in Western Canada. That's my song and dance right there, is alfalfa, alfalfa, alfalfa. I think there's been more money lost from the fear of bloat in your pasture system than actually utilizing alfalfa in a binary mixture with the grass to reduce the incidence of bloat, or maybe sandfoin, or maybe some type of bloat aid, or maybe grazing it at whatever 30% flour, okay? So you should have alfalfa in your rotation, because guess what? 78% of the atmosphere is in. Why not through that BNF, the biological nitrogen fixation process? Why not? If you don't like alfalfa, then maybe you go to Sicer, okay? It has a venation pattern in the leaf. It takes longer to get established. You might not get everything in year 1, but by about year 2 or 3, you might see more of it in your stand. Sandfoin, we've been looking at it. It came out of actually Lethbridge program here. We have the AC Glenview now versus the Mountain View. It tends to be higher yielding and higher quality, but in my mind, it's persistence. How long will that species be in stand? So I'm going to talk briefly here, just to wrap it up, about a long-term study I have going at Clavette, kind of a unique system where I'm looking at a perennial system versus 2 annual systems, so 2 perennial, 2 annual. And this is a 140-acre site, okay? 3 reps of each treatment, 4 treatments, and we're looking at a multitude of things. We're looking at yield and quality, steer performance, and enteric emissions. I team with the soil scientists at Shano's lab, Ryan Hang's lab, Bobby Helgeson's lab. Okay, soil water balance, that's Fonstad, my engineering colleagues. Yes, I get along with engineers too. And of course, economics, right, with Kathy's group. This, my friends, is how we measure enteric emissions from a grazing ruminant. So my crew is pretty good at this. This is the one technique, it's called sulfur hexafluoride. And what we do is we put this fancy little necklace on these guys. It's a 1 liter negative chamber yoke, PVC pipe, and then of course a halter to capture those nasal vapors. Then we let them out of the chute and they go that way about 50 miles an hour because they hate it. And so then we have about a 3 or 4 day adaptation period if they don't wreck it. And if they do wreck it, they come back in, they get a new one. But my crew is pretty good. We put a perm bolus in their reticulum, so a slow release sulfur hexafluoride bolus, and it's the ratio of SF6 to CH4 that we're actually measuring from those nasal vapors. Very intensive way of measuring enteric emissions, about a 5-6 day period. We do that 2 or 3 times throughout the grazing period. That's an older version, and I validated it with this, which is a much newer version. These are called the green feeders, okay? And they come out of Rapid City, South Dakota. They're a trailer system. They're sitting about $200,000 US right now. And I was lucky enough about 10 years ago to see the writing on the wall, and I have a couple of them in my lab program. So what do? We trick that girl or guy with a little pellet treat. And so they hear a little sound, they come in. We need their nose in that head chamber about a 2 or 3 minute window, and we can capture nasal vapors levels of O2, CO2, and CH4 in real time. About a 2 or 3 time span they need to be in that head chamber. And it goes up to a cloud, and so kind of a more modern technology, if you like, compared to the SF6. Okay, in this long-term 5-year study, of course, alfalfa's out there. There's my Mountain View sandfoin. And I'm going to touch briefly on the annual legumes. Okay, this is just my opinion. I'm sorry I see some of the seed booths are selling these annual legumes. They are not persisting where I'm at dryland, Clavette, Saskatchewan. Okay, they're kind of a Oregon, Washington state, kind of a maritime type climate. But certainly in each of our annual systems, we had a legume, and we looked at frosty persimmon clover. What about the grasses? Okay, obviously there's your hybrid brome grass. That's a dual-purpose grass species. You can hay it, you can graze it. It's kind of a neat selection for those producers who don't want to put a lot of thought into pasture management. You can put it in there, you can graze it, and then you can hay it. The one in the middle, the meadow brome grass, is probably my favorite pasture grass. It should be in every pasture species, not smooth brome. Smooth brome's a hay type species. And there's your fall rye. Probably the best winter cereal that I've worked with compared to winter wheat or winter triticale, and I always do suggest fall rye. We're looking at some of the hybrids right now, the Bono and Bersato, And there on the bottom, we're hearing a lot of conversations about polycrops, cover crops. I'm growing them for grazing, okay? You might be growing them for other benefits, but I'm growing them for cattle feed. There's a very simple one, a barley, a pea, and then some brassicas. It doesn't always rain at our site, okay? We don't have irrigation, we're dry land. So I'm trying to do research on about 3 inches of rain in normal 10 to 12 inch rainfall area, long-term average, okay? But my results are reflective of what you're experiencing on your farm or your ranch. So we're getting about 340, and we're getting a lot less than that each year. There's our biomass, there's our yield. You can see our hybrid brome alfalfa came out of winter, our metabrome sandfoin, our fall rye clover, mostly fall rye, very little berseem clover, and there's our simple polycrop. This is the interesting part, and this is kind of Shano's lab, Jeff Shano's lab, and so what they're looking at is soil nutrient supply and microbial biomass, carbon, and nitrogen. And what he has is these little PRS simulators. So he's put these probes in about 6 inches and can measure the level of nitrogen and phosphorus supply rates. So with those PRS, we look at those 4 treatments, okay? Again, it was the hybrid alfalfa came out of winter, second to the simple poly, and then followed by the metabrome sandfoin. What about microbial biomass and carbon and nitrogen? So that's indicating, you know, the microbial carbon and nitrogen in the soil organic matter. And again, we see that, again, it was the hybrid brome alfalfa that kind of came out ahead. Good old alfalfa, queen of the forages, right? And so I keep going on about it. The results of this long-term study, very similar with that work at Lanigan with Isaiah, looking at that sod seed work that we did. There's a 5-year program, okay? Weights of our steers out there, and ranging from 1.3 to 2.2. So a pretty good backgrounding program going forward. I'd probably want to retain ownership and get the compensatory off those steers, right, for the next owner. What about methane? Well, we're seeing, this is some of the green feeder data, we're seeing some reduced levels in those legume perennial forage species. There's our sandfoin and there's our alfalfa, okay? So reduced levels, this is just a snapshot. Again, we're continuing to collect that data and come up with a long-term multi-year implication. I'm just going to wrap up here and talk about a couple of programs that are out there. CRSB, Canadian Roundtable Sustainable Beef. It's been around now for about 8+ years. Many organizations, companies are part of that. In fact, I think I was one of the ones that actually reviewed the application for funding for this to get it going, and I think it's something that we need. And then so really the question is, what is sustainable beef, right? So they're saying it's a socially responsible, economically valuable, and environmentally sound product raised off of those grasslands. The other program we're involved with is Living Labs, and I think there's 9 of them across Canada. There's 2 in Saskatchewan, 1 Indigenous, and then 1 at Central Prairies. We're involved with the Central Prairies Living Lab, and we're working with 20 producer sites in the province, integrating those BMPs, which you heard about earlier. So they're integrating cover cropping, sod seeding, fertility management, and in my mind, this is a good 5-year program that's going to get more producers integrating those BMPs than probably didn't even think about them prior to that program going forward. All right, just some data suggesting about the reduction of the carbon footprint by the beef industry in the last 10 years, since 2014. CRSB has just released a shrinking greenhouse gas footprint, 15% less. Due to what? Due to the performance enhancing technology that we have, okay? Some of you may have heard that Bovaer just got approved to be used in Canada. That's the 3-NOP, right? It's a feed additive owned by DSM, who's probably in a good situation to make millions of dollars of selling their product. I'm really challenged on whether it's going to be good for the cow-calf sector, probably more so for the dairy. Okay, just a summary. Soil organic carbon impacted by what? The grazing intensity, the soil type, the plant species, climatic factors, legumes should be in your rotation. And enteric emissions can be reduced. Yeah, when you integrate those tannin legumes into your rotation system, but we need to continue to do the research to better understand the complexities of the interaction with the soil, animal, plant, water interface. Very, very complex. My last soapbox verbiage is that the beef industry is very important to the environment in this country. There's a lot of acres out there, marginal land where you can't grow a cash crop, but we can graze a cow out there and it's a saleable product. The producers have been managing these resources for decades. Kudos to them. I think we're in a situation where we have to realize that it is high quality feedstuffs, but the next thing is that we have to figure out how to compensate them for the carbon that they have sequestered over generations in those resources, be it native range or be it tame pastures. So thank you for your attention. There's my crew, the reason I can travel around and visit with everybody. And my website, you can click on there and you can watch a video where you can shut Bart off after 1 minute. You could not do that this afternoon. Thank you.
Thank you. Any questions for Dr. Bart? Hi. You're talking about your high tannin legumes. Does bird's foot trefoil fit in as a high tannin legume?
Yes, yeah. I had bird's foot. It does. It's more of a wetter type climate legume.
Yeah. I'm from PEI, so that's probably
Yeah.
why I know a little more
I'm
about
envious
it.
of you guys.
Okay.
And I was just down there about 2 years ago looking at the Nova Scotia researchers, forage breeder Joseph Papalopoulos.
Yeah.
And he has alfalfa, he has bird foot that I'm envious of because you guys get rainfall.
Yeah.
Which is needed. But yeah, bird's foot is a tannin legume that would work for you guys.
We normally do alfalfa and white clover in our pastures, but we're looking at trying to put maybe some more bird's foot trefoil in if they'll eat it.
Yeah, no, it too is a non-bloater. You know, you mentioned white clover, absolutely. The other best kept secret is red clover.
Yeah.
You know, I talked about alfalfa, but red clover, we did some short-term rotation forage legume work showing the fertilizer equivalent after growing and plowing down and after 2 years. And red clover came out ahead of alfalfa in the dark brown soil zone. So kind of interesting.
Thank you.
Other comments? Yeah, Graham. Give the man a mic.
At the end of the day, Bart, I have an economics question. So between the 15% that CR came about and the work you're doing in the economics, have you finally nailed down or have a good idea what the abatement cost is to capture that reduction or avoidance of that 1 ton that you're trying to either get out of the fermentation or you're trying to get out of the soil, to understand the economic side of that reduction or avoidance?
And you asked that question knowing I can't answer it.
Sorry.
No, we have not got there yet. I think what I have to do is work with those modelers that are coming up with those releases like CRSB. So I'm just over here at Lethbridge Canada for meetings here this week as well, and I'm working with the Holus model. It's out there as well, and it's up to us to input our field data, our study data to better perfect the outputs of that particular type of modeling system. And it's going to be a long-term commitment, probably a 5-10 year program. So.
Hi, Bart.
Yep.
Ken Coles here. Thanks for your presentation. I'm not sure if you were here in time, but I spent about 10 weeks traveling the world, and I paired up with a number of what I consider hardcore regen aggers. Visited the Allen Savory Institute in Zimbabwe. I guess my question is, and I don't know if it's more so in the cow-calf world versus the crops, but that battle between science and pseudoscience seems to be raging rather severely. And I think that a lot of these groups are anti-science at times and ideologically based. I'm just wondering what your thoughts are. And it's kind of the Gabe Browns of the world and so on that really capture the media attention. But how does the science part of it come out a little bit more clearly?
Yeah, that's an interesting observation, and I have so far kind of been in the wings, not being out front. I find myself more and more in the front of groups talking about that as a scientist. What I see, Ken, is that there are some people that are very evangelical of getting a message across. In fact, the Western Canadian Soil Health Conference is coming up in December of this year. Apparently someone said I'm going to be speaking at it, and that's okay, because I tend to listen to a lot of those presenters, and they tend to be very evangelical. A lot of pictures, not a lot of data. Okay, I'm a data guy. Okay, and it's the same with the cover cropping when we're growing it for grazing cattle. We're hearing lots of claims about improvement in this, soil health, you name it. It's up to us to do the field work and to try and validate those claims. Okay, little did I know when I started out back in 1998 at Lanigan that I was doing regenerative ag research, but apparently I am. I was just trying to do something good for the beef industry. Okay, but yeah, I do caution when you hear something that's too good to be true, it probably is. So there's no silver bullet in this industry. There's lots of BBs, but there's no silver bullet. My take. Yeah.
Thank you for the presentation, Bart. What we struggle with also from Saskatchewan is the longevity
Yeah, I
of
know
our
your
legumes. So,
Your brother keeps bugging me.
oh yeah, well, it bugs me too. Anyway, yeah, I mean we struggle with the longevity of legume pasture mixes. I mean, it good for obviously into old farmland, good for a while, but it dissipates pretty quickly, especially in these conditions.
Yeah. Under dry conditions.
Well, I mean, even normal, like, I mean, you know, we're from in Wood Mountain. It's
Yeah.
it's always dry, but
Yeah.
we struggle with that long term. I mean, it establishes well, and then it just dissipates. Even
We're talking alfalfa?
yeah,
Yeah. Well, then I would probably suggest, have you tried Sisa milk veg?
not really.
No. And Sisa is a hard seeded. You have to do your homework when you're going to seed it. You have to be patient. But it is hard to establish long-lived. That's a rule of thumb. Easy to establish, short-lived. Hard to establish long-lived. So I would suggest for your guys down there, I would maybe try just a little bit of that Sicer and see. It is very long-term. It can be actually quite aggressive, and we've heard that it's very competitive in some situations. But at least it's a legume. So, other comments?
Since we have time, Bart, I also saw a lot of fodder beets in different places. Is there any potential for that in Canada?
Fodder beets was the question. I came back from the UK. I was over there just before lockdown talking to the Welsh and the English producers. And what they've done, and I just got a text today to go and talk in Montana here, but they have taken our extensive grazing systems, like our be it corn or bale or stockpile forage, whatever, and they are doing it over there, but they are more regulated than we are in Canada. So that cow has to be in that barn throughout the winter months, slatted roof barn. We don't have that restriction here in Western Canada, usually. And so they're adopting those practices they see that we're doing. They call it outwintering. And fodder beets is one of them. And I came back thinking, you know what? Is there a potential? And in my mind, you know what? In certain areas, probably, but it too would be moisture restricting. It would be. So, I mean, I seen how they're growing like winter wheat in Kansas at first hollow stem, where they actually grow it, seed it, graze it, and then they get a grain crop. Wow, wouldn't that be novel at Clavet, Saskatchewan? Just saying. Other comments? All you need is rain. Yep. Yeah. But they can grow corn. We can grow corn here too. So. Oh yes. Thank you.
Thank you. And thank you to you.